So the next topic of discussion is graphing radical functions. We talked about how to graph rational functions. We learned that we had to find all the characteristics necessary, such as vertical asymptote, horizontal asymptote, holes, domain, range, x-intercepts, y-intercepts. All those things went into being able to sketch a rational function. Well, now we're talking about sketching. And again, I emphasize the word sketch. Sketching radical functions. Now, radical functions are not always just square roots. Sometimes they're cube roots. They could be fourth roots. We're not going to go to the fourth roots. We're going to stick with square roots and cube roots. And what we're going to do is we're going to learn the details, the basics of what the parent functions look like. And then we're going to always relate back to the parent to determine what the new function is going to be. So, first thing we need to write down is what the parent is. And I have a little wall of functions over there, and you can see it on the wall. But the parent square root function is y equals the square root of x. That's your parent. Now, the parent is where all the other similar functions come from. We always relate back to the parent function. Now, the parent square root function looks like this. Now that's a sketch. It's not perfect. It doesn't need to be perfect. We're just sketching it. Okay? But there is a very detailed aspect of this graph. That is where it starts. Where does it start? What do you call this point?
The origin.
The origin. So it gets its start at the origin. So basically what we're going to do is we're going to take that origin, that shift point, and we're going to shift it around the grid, and then we're going to make a sketch, a new sketch, which is going to look just like the old one. All right? Now, back in 9th grade, most of y'all were in my class, I taught you how to do transformations, and we did several transformations. We did vertical shifts, we did horizontal shifts, we did reflections, and we did stretches and shrinks. All right? Now, those things are what we're going to use, those transformations are what we're going to use to make a sketch and to determine the domain and range of whatever function we're looking at. Now, let me go through these transformations real quick and refresh your memory. And somewhere on the page you need to write this stuff down. I know I'm going to be writing over some things, but let's see if I can make things look a little better here. Okay. All right. Now, the first transformation that we need to understand is the horizontal transformation. So a horizontal shift. Okay. A horizontal shift is going to be left and right, correct? So if I have something added or subtracted to the x value itself, that means whatever's underneath the square root when it comes to these roots, adding to that or subtracting, that's going to cause it to move horizontally. Now, here's the tricky thing about horizontal shifts. When you're adding, it's actually going to move the opposite direction. So if I'm adding to the x, I'm going to move to the left. So if I added a 2 right here, which way would I actually move on the grid? To the left. Let me do that. I would move left. All right. If I had an x minus 3, which way would I move?
To the left.
I would move to the right. Because I'm going to move in the opposite direction of the sign. Normally, positive is to the right, correct?
Yes.
But when it comes to horizontal shifts, you move in the opposite direction. It all gets related back to the same concepts that we've been learning about when we solve quadratic equations. We have to take the opposite of what's in parentheses to get the answer. It's all related to that. Why? Because x values are your roots or solutions or x-intercepts. All right? So how do you solve something? Well, on a graph, it's wherever it crosses the x-axis. All right? All right, now, on the left, again, x plus 2 would mean left 2. X minus 3 would mean right 3. So that's how you do a horizontal shift. So then we have our vertical shift. For the vertical shift, you're taking whatever the function is and adding a number outside, or subtracting a number outside. So if I do the square root of x and then out to the right, and it actually could be in the front also, but if I'm adding a number to the square root function, the parent, then it's going to cause it to go up. This would be up 2. If I subtract the number from the square root, the original function, it goes down. So this will be down 3. So you're moving in the same direction as the sign when it comes to vertical shifts. All right? Now, I'm not going to write down the other ones. They are reflections and stretch and shrink. But I will briefly say that when it comes to a reflection, all right, there's a negative out front. It's going to cause the graph to simply flip over the x-axis. Doesn't mean I have negative x values. It just means that the y values end up being negative. All right, when it comes to your stretch or the shrink, when you multiply by a number, it's going to cause it to either stretch vertically or stretch horizontally, which we call a shrink. Okay, I said that wrong. It's going to stretch horizontally or it's going to shrink horizontally. I said it wrong again. Get it right. Stretch vertically or shrink vertically. We're not going to worry about horizontal stretches and shrinks. Now, we're not going to have to do too much with that because when I'm doing a sketch, you can't see what the stretch or the shrink is when I'm doing a sketch. Okay, you can't tell. So we're basically going to ignore a stretch or shrink for our sketches. All right. With all that, now how do I use those transformations to determine domain and range of a function, of a square root function or a cube root function? Well, this is how. First of all, this minus 2 tells me to do what?
Go to the right.
Left, right, thank you. You're right. It means go right 2. And what does the plus 5 tell me to do?
Go to the left.
Left. No. The plus. Up. So when it's up and down, it's the same sign. The sign is the same as the direction that you go. When it's left, right, it's opposite. Now, what this means is I just took my origin from where it was originally and I shifted it to the right 2 and up 5. Right 2, up 5. So now it's up here somewhere. It's the same graph. It's just shifted up, right, and up. Now, what does that mean for my domain and range? It's very simple. Wherever I start with my x value, that's where my domain starts. So, the domain for this problem would start where? At 2. And where would it end?
Infinity.
Infinity. Now, I know I can't contain infinity, so I use a parentheses. But am I including the 2?
Yes.
Yes, I am including the 2. It's part of the graph. So what symbol do I use when I'm actually including it? Bracket. Very good. Excellent. So that's what it looks like. So the domain for these problems is very simple. The range is also simple. The range for this problem is going to start where? At 5. So again, bracket. And it's going to end, it goes up forever. I didn't make a great drawing, but it goes up forever. It just goes very slowly, rises very slowly, but it does that forever. So that's going to be infinity. Okay, so there you go. So that's our domain and range. Now, you would do number 2 in the same way. Let me talk about number 3. Now, number 3 is a cube root function, which means it's not going to look exactly the same as a square root function. We can use the calculator. We can plug this in the calculator and we would see exactly what it looks like. All right, but I'm going to go ahead and save a little bit of time and just tell you. Now, You look over on the wall of functions, you see the x cubed. The x cubed. X cubed looks like a propeller, but it's vertical. Alright? Guess what's going to happen when we do cube root? You're going to take that propeller and flip it, but here's how it's going to look. You got your top part, which looks just like the square root. But then you also have a lower part. Okay? So that's your cube root sketch. This is what the parent cube root function looks like. Now, notice I have some negative x values over here. That's allowed for a cube root because if I take the cube root of -8, what do I get? What's the cube? -2. You can take the cube root of a negative and get a negative answer. But can you take the cube root, the square root of a negative? No. Unless it's imaginary number system. This is not. This is all real number system. Okay? So, for square root, I can't have any negative x values. But for cube root, I can. That's why we have this negative portion here. Alright, now, again, what does this +1 tell me to do? Left 1. What does the -4 tell me to do? Down 4. So, what part am I shifting? The origin. That's my shift point. So, I'm going to shift this bad boy left 1 and down 4. It's down in here somewhere. So then it just looks exactly, it looks exactly like the parent. It's just shifted down, left and down. Okay, so this stuff's super easy. Now, that's how you graph it. But what about domain and range? Same deal, except this is easier. Just because I moved it to left and down, did it change where I start and finish? Why? Because what are these things doing forever? To infinity, left and right, and to infinity, bottom and top. Therefore, your domain and range are exactly the same for square root, cube root functions. They are from -infinity to infinity. You could also say all real numbers.
So do we have to put in
Okay? It goes from -infinity to infinity in both cases.
So to put 2 parentheses, right?
It's got to have parentheses because you cannot include infinity. You can't contain it. Alright, so the next thing we're going to take a look at is just the actual graphs. So let me scroll down a little bit. I actually want to go down to number 12. So look at number 12. It's on the right side of your paper. Alright, notice number 12 is a cube root function. And notice that the -2 is in front. It's still the same thing as it being in the back. It just helps us not mess up. It helps us not confuse what's supposed to be under the square root and what's not. Some people, they don't draw neatly. What they will do is cube root of x and then -2. So is the -2 under the square root, under the cube root symbol, or is it not? We don't know because they're not precise. So what some people do is they just put the -2 in front. Now it's not being multiplied, it's being added, but it's in front. Now, another thing you can do, just to make sure everybody knows what you're doing, put a little tail on the end of the radical. Because if you do that, then everybody knows if it's to the right of that little tail, it's supposed to be outside. If it's to the left of the little tail, it's supposed to be inside. Alright, so what are we doing to our shift point right here?
right 2?
Just to the right.
No, down 2.
Wait.
Down 2. There is no left or right because there's nothing being added or subtracted to the x. Okay, so I just go down 2. And then write the parent. Redo the parent. It looks like this. It doesn't have to be perfect. It's a sketch. That's all I care about is the sketch. Except I do care about where that shift point is. That's extremely important. Alright. The next one I want to look at, I'm kind of working backwards here. I want to take a look at number 10. Alright, number 10 is another cube root function. I'm not going to graph it, but I want to emphasize something. Notice the 1/2. 1/2 would be a shrink by a factor of 1/2. I cannot sketch a shrink. I can't do it. All right? So we're not going to worry about it. We're just basically going to ignore it. If I was graphing it precisely by plugging in x's, then I could, do something about it. But I'm not. So I'm not going to be. We're not even going to worry about it. Okay. Now, there is a way you could be a little more precise with it, but again, I'm not worried about that. I really care about the shift point. The way that you would be more precise is this. You would treat the 1/2 like a slope. So my shift point would be left 1 and up 4. Said I wasn't going to do it, but I am. Then I would treat the 1/2 like it's a slope. So to get my second point over here, I'll go up 1, right 2. It just makes it a little bit flatter than it normally would. All right, so where would my other point be? Down 1, left 2. That's all I would do. That's all the little slope, the little factor in front. What it does is it basically just makes the slope a little less or a little more, depending on if it's a stretch or a shrink. All right, but I'm not going to emphasize that too much. On number 9, I want you to notice that there's a negative, so what does that do? It reflects it. You can treat this -2 like a slope if you want. So when you do your shift point, from that shift point, go down 2, right 1, and you've got, a little bit better sketch. All right, so I'm going to stop it here. You're going to do the rest of the problems on the worksheet. Number 13 is your ticket out the door. So know that.